Whenever you're ready.
Good afternoon, my name is Jacob Nelson from Cousino High School.
I'm Jonathan from Fraser High School.
And I'm Henry from Silvermats High School.
And this is our presentation on
The burning bridges.
what we chose to participate in this year for our 20% project was the MDOT track bridge building competition.
So why we chose to do this? I personally chose to do this because I want to go into career in engineering, and also Mr. Gravel said to.
I chose to partake in this one because I also want to become an engineer, although I want to become more of an electrical than civil, and Ms. Gravel, again, mainly told me that we need more people, it's really fun, you should do it.
Similarly to my partners, I was also recommended by Ms. Gravel to do this, as well as Kushi. I was also informed by Ms. Gravel that there are positions that are in high demand of a civil engineer, and this is a great way to start a career path like that. So the MDOT track bridge building contest is an annual competition held in Grand Rapids, Michigan. The applicants are to build, test, and design a bridge, and this year's topic is a cantilever through truss bridge. The prize is an internship at MDOT.
So just a little bit of terms before we get started here. The cantilever, by definition, is, if you can show ours, here's our beautiful bridge. This is not what ours actually looks like. Ours is more broken up. So just a couple terms to know. A cantilever, by definition, is a long projecting beam or girder fixed only at one end. But an easier way to think about it is this entire area right here up until about right here. It's kind of hard to see, but there are kind of little dots right here, and that is where this cantilever stops. And the suspended span would be this right here. This arrow's a little low, I'm sorry. This would be this area right here in between the cantilevers.
So what is a cantilever bridge? A cantilever bridge is a bridge that has two cantilevers on each side, and it also has they suspend an area in between. And also, it's just more known as a bridge with two steel triangles on the end.
Bridges are very essential to most cities, as most cities are formed around bodies of water such as rivers and lakes, such as ours. They help with transportation over bodies of water and land.
So what is this bridge made of? It's mainly made of balsa wood, wood glue, sweat, tears, determination, and a little bit of Henry's blood, because he can't end up actually getting the needles in to stabilize the bridge.
So before we begin, some of our regulations that we had for the 20% project, one of them was we can only do a one-layer lamination. And so if this is our piece of crappy balsa wood, you can only put one other piece of balsa wood on top, nothing more and nothing less. Now the main reason that people would want to do a lamination is because it doubles the strength of the balsa wood, which is a very, very important thing, because as we've come to know it as wooden foam, it is very, very easy to break. Another one is the suspended span can only be 1/2 the height of the cantilever. So for our exact bridge, our cantilever is 3 inches, and our suspended span will be 1.5 inches. And one more thing, the joints cannot be more than 3/8 of an inch. To give you a little insight on that, each piece of balsa wood is 1/8 of an inch. So you can basically not have more than 3 pieces of wood per joint.
So our initial start was that we just jumped right into building without any knowledge of actually cutting the wood or building it. That's where we started off with. And right here is where we have gone so far. This piece right here is the road, and this connects with the side of the bridge, similar to this. And the other side would mirror that as well. Though we have a lot more work to do.
As can be obviously seen. So a couple of our basic designs. One of them, this was our very, very early design, and here's a close-up of it. So this is a close-up of our first design. We've come to know this as the Star of David design. As you can probably tell, all these crazy amounts of heavy wood all added together end up making a Star of David design. This design is actually very, very effective. However, as I mentioned before, you cannot have more than 3 pieces of wood per joint. So we did find out that this was in fact illegal.
And this is our current design. As you can see, we have many triangles right here. Triangles actually help to support the actual bridge, their structure. It's a whole lot harder for them to collapse than squares or rectangles or shapes like that. So we have a lot of these in our actual cantilever part, and then across the suspension area, we have several of those as well. And this is a close-up.
For our first design, known as the Star of David, it held roughly 96 pounds, and our current design held 25 pounds.
Some struggles that we've had through this emotional bridge journey, one of them being the wood breaking. As I mentioned before, we call it wooden foam. It can break very easily with a very, very little amount of pressure. Secondly would be the heavy regulations. There's not much you can do outside of what they tell you. A third one is just really overall stress. The bridge isn't technically due until March, but there is a lot of things that we still need to do between proposals and submissions and just testing our bridges, doing more research, portfolios, and a bunch of other things that would take forever to list. Another one is finding time after school. We all have busy lives in different ways, so it was very hard for us to all find a time when we could all come together to work on the bridge. So that's been our main struggle. And finally was the daily journal, which we only found out about a week ago. And basically that is, yes, thank you, Kushi. That is basically every time you meet, you're supposed to keep a record of what you do, and we did not do that at all. So when that time comes, we'll have to start making things up. So that should be fun.
So these are some of the real world applications for building bridges. Is civil engineering, also architecture and structural engineering, and these are very important because our society is very busy. So a lot of ways of transportation are needed, and some people can't afford to fly in airplanes or go across oceans. So one main way to get across regular bodies of water is structural bridges.
Advice for our future bridges, as we like to call them, is to stay organized. We ourselves didn't set goals each day when we met up, and that was something that we should have worked on and should have done. We should also pick teammates that have regular schedules that you can meet up. You should also pick teammates that you know will get work done. You should also find time after school, as said before, and you should also do the daily journal.
So in conclusion, what we've learned is that building a bridge is very, very hard, and it's also giving us great insight into what civil engineers do every day of their life and the real struggles that everyone goes through when they're trying to build a bridge. We've also learned really good teamwork skills, as building a bridge is not very easy to do by yourself, so it requires at least 3 people in our case. And what we plan to do in the future, this is rather vague, but we really just hope to win. We also plan to so besides winning, we also mainly just plan to become more organized and hopefully get at least one bridge done. Right now, the one that we have right now is more really of a test one, so we hope that we'll be able to get a very good working bridge done by the time March is over, and pretty much finish up everything that we still have to do between proposals and submissions and all that other fun stuff. And that's about it. Any questions?
Nice job.